and welcome back to my broken TW200 welding series. I've already fixed the cracked subframe brace that supports my rear rack and the broken muffler bracket. And this frame crack right behind the right foot peg is the last thing I need to weld before I can finally put this thing back together and go riding again. So let's go ahead and get this thing started.
I only found this crack after a close visual inspection of the frame. Most likely it was caused by the hard use I put this bike through while riding. Good thing I found it sooner than later because cracks like this can only get worse. This is a structural part of the bike's mainframe, and I'm honestly not sure how well this will work, but I'm willing to give it a shot. One thing I would not attempt to repair is the steering head. I gave it a good inspection and couldn't find any cracks. It appears to be very well made, and if I do find any cracks in this area, I would just buy a brand new OEM frame for around 700 bucks. Really quick, since my bike is always dirty, I'll go ahead and give it a good wash. To get better access to this area, I'll have to remove a bunch of parts. In the last video where I repaired the exhaust bracket, I end it here with a lot of parts already removed and the exhaust attached. If you need to see how I removed everything, I'll leave a link to that video in the upper right hand corner. I'll start by removing my DG slip-on exhaust. It's just one 10mm and one 13mm bolt and it slides off. On the right side, I'll use a 5mm Allen wrench to remove the two bolts holding the passenger peg on. Next, I removed the wing nut for the rear brake shaft by turning it counterclockwise. Pull the shaft out of the brake lever and the pivot cylinder and spring slides off. The rod for the rear brake sensor just unhooks from the brake pedal. And so it's not just flopping around, I'll unhook it from the sensor. I use some needle nose pliers to just barely bend the loop out of the way so it can be removed from the spring. Next, I'll unhook the brake return spring. Then I used an 8mm Allen on this little impact driver to remove the right peg bracket. The bottom bolt came right out, but the top one would not move. I then very carefully used an actual Allen wrench to loosen it by hand, and you want to make sure it's all the way in and not to put too much pressure at any angle or you risk rounding it out. These seem to have quite a bit of Loctite on them. Now the brake pedal will slide right off the shaft. Next, use a 10mm to loosen this nut and then you can spin out the brake pedal stopper bolt. I'll go ahead and remove the passenger peg bracket on the other side as well. This one has a small wire holder bracket on the bottom bolt, so be sure not to lose it. I'll use a 17mm to remove the single bolt for the left side peg. If you haven't already, remove the chain cover held on by two 8mm bolts. Position the bike so the chain master link can be accessed. I just used some needle nose pliers to remove the master link clip. This master link is a pretty tight fit, so I'll use a chain breaker to carefully press out the link. Be sure to press a little at a time as you alternate sides or you risk snapping the master link. If you have a sealed chain like I do, be sure not to lose the sealing rings. If the bike is in neutral, the chain will now slide right out. I have the Ricochet off-road skid plate, so it's two 13mm bolts on the front and two T40s on the rear. You should be able to leave the rear ones on just barely threaded into the clamps and it should slide off from the frame. The TW200 has an interesting frame design where the engine is actually a critical structural part of the frame. The front of the frame attaches to the crankcase and the rear of the case attaches to the swing arm and the frame, which you'll see more of in a moment. Then there are small mounts that attach the motor to this lower tube, and there's also another mount on the cylinder head that attaches to the top of the frame. If this crack were to break all the way through, I don't believe it would be immediately catastrophic, but it would quickly put further stress on the other welds. So that's why it's important every so often to inspect the frame on any bike you ride hard off-road. I'll go ahead and remove the shift lever as well. It's just a 10mm bolt, then it wiggles off. Next, as you can see, the swing arm bolt is kept from spinning by this little notch, so the lock nut on the left side can easily be loosened with a 19mm. Then I'll remove this rubber cap around the nut for the upper shock bolt and hold it with a crescent wrench as I loosen it with a 14mm. Before I remove the bolts, I'll get my motorcycle lift out and start jacking up the bike. I found placing one pad under the rear bottom of the frame and one pad supports the engine case works the best. Next, I'll put the kickstand up, use some vice grips, clamp clamped onto the spring and carefully unhook it from the kickstand and slide off the bracket. Then I'll use a crescent wrench to hold the lock nut as I remove the bolt with a 17mm. With the rear tire just barely touching the ground, I'll tap the bolt out with a punch and hammer. Then I'll do the same with the long swing arm bolt. Taking it out was a little more difficult, but I found rotating it and moving the swing arm up and down helped a bit. Now the swing arm will disconnect and you can carefully pull it out to the rear as the shock slides down and out. I'll just roll it over to the side like it was a wheelbarrow. Wow, the TW200 is really starting to look a lot lighter, but now I can finally get to those cracks. Removing the engine might be a little bit better, but I think I can still get to that inner crack with it installed. Instead of trying to weld this on the lift, I'll use an old tire to lay it down on. Picking up the rear end of this bike was much easier than I thought it would be. Now I can lay it on either side. As a side note, make sure to wear proper safety gear for the task you're undertaking, and be sure to read the manual for any power tools or welders you may be using. Also, if you're going to be welding, it's not a bad idea to have a fire extinguisher nearby just in case. Next, I'll need to remove all paint and primer in this area around the cracks. I'll start with a steel wire brush on a drill and get as much as possible. Then I'll switch to a Dremel and a tiny steel brush to get the paint off in the smaller, harder to reach areas. Once that side is done, I'll flip the bike over and clean off the other side. It takes a bit longer than I expected to really get past that primer. Also, the small steel brushes can wear out really fast, and any of the steel bristles can fling off at you and it doesn't feel too great, so be sure to wear some eye protection. Alright, now we can get a much better look at what's going on. The cracks on the rear appear to be originating from this hole where the outer sides are paper thin, then as the hole gets deeper, the walls get much thicker. From my understanding, the purpose of a hole like this is to allow gases to escape when the frame is being welded at the factory. It also seems like it would allow any water that finds its way into the frame to flow or evaporate out. The crack on the outer side of this hole moves all the way here and maybe splits off here and here, but I can't tell for sure. The inner side has a very obvious crack that runs to here, and at least I got to it before it got to the toe of this weld. There's also a crack that wraps around the front of the same tube and appears to possibly follow the toe of this overlapping weld. That pinhole is just a superficial defect from the factory welding. This crack also wraps around to the inside, and the crack is a little hard to see, but a mirror makes it easier to spot. Hard to tell in the video, but this thing here does not appear to be a crack, but instead a superficial defect when the end of the tube was pressed into shape. Just like the first welding video, I still think it's a good idea to drill out the ends of the cracks before welding them. I had explained it's just like a small tear in a chip bag where if you only put some tape over it, the tear can still easily get worse if you ruffle the bag around. However, if you cut a tiny circle at the end of the tear and then put some tape over it, the crack no longer wants to spread. I'll use a center punch and hammer to mark the end of the inner rear crack. It's not a bad idea to go a hair further than you can actually see where it ends. Then I'll drill it out with the smallest bit I have. I'll do the same basic thing to the crack on the other end. I won't drill all the way through on this one since both sides are crimped together. Next, I'll use various diamond tipped bits on the Dremel to basically make a groove that follows the crack. This will make it easier to follow with the welder, and it gives it a bit more surface area for the weld to hold on to. I'll follow it around the corner using a mirror. Then I did the same with the other crack on the rear. Now I'll just flip the bike over and basically do the same thing with the cracks on the other side. I only need to drill through the weld and the first part of the tube, which is 14 gauge. From afar, it seems like this could be a crack that reached all the way across, but when I looked really close, it just looks like the toe of the weld, but just in case, I will run a weld over that as well. I'll just run another groove over these cracks and blow off the metal dust, and it's ready to be welded. Before I get started, I'll just practice with some of these pre-cut and clean 14 gauge steel scrap pieces. Since I'm using 030 in this machine, I'll start with the recommended setting of 4.5 wire speed and between D and E voltage. This is a good place to start, but you can always fine tune it as needed. If you're not getting enough penetration with a lot of random metal balls and you're not getting a proper puddle to form, you'll either need to turn up the voltage or turn down the wire speed. On the other hand, if you're getting too much penetration and the bead is sinking too far down into the metal, metal, you will want to do the opposite. Also, when welding thinner steel, you will want to only do a little at a time, or else it quickly becomes saturated with heat and you can blow a hole right through it. Here's what I was able to do. I butt welded 2 pieces together, which is basically what I'm going to be doing with the cracks. Definitely not the best looking weld, but it should be very functional. I'll insert the swing arm bolt to keep everything lined up. Next, I'll clean off this bracket as a place to attach my ground clamp. It's good to have a good clean ground as close to the workpiece as possible. Next, cover up the exposed parts of the bike, attach the ground clamp, and I also have a socket over the brake lever pivot to keep off any spatter. I'll start by filling that hole and following the groove on the right. I'm using a flux core welder, so it's best to clean off the slag after every weld. This is that dirty stuff that appears on top, and it's actually what protects the molten steel from oxidation as it cools. Another thing you will want to do after every weld is cut the end of the extra wire off, so there's around 1/4 inch left hanging out. This will allow you to start the arc much easier. I may not show you that after every single weld in this video because I don't want to bore you too much. This spot worked out pretty well. I started to follow it right around that corner. Now I'll begin on the left side just a little at a time so I don't blow a hole through it. As I made my way up to that hole, I dwelled a little too long at one point and I blew a hole right through it, unfortunately. That stuff in that area is almost paper thin, so I knew it might happen. I didn't give up though. Little weld by little weld, I built that space back up. I also laid down a few more beads in this area, and I also turned up my machine quite a bit since I started laying welds over welds. I called it a night and left off here for the next morning. I didn't get proper penetration in that upper tube with the last bead. This was in the late fall and the ambient temperature dropped quite a bit. Probably could have used a bit more voltage. Plus I left this little crater right here, and that's when I gave up for the night. Sometimes when you run into problems, it's a good idea to sleep on it and get a fresh start the next day. You want to try and avoid having a weld bead curve around like this before it inserts into the base metal. It just won't be as strong. The next morning I dremeled out the edge of that bead and cleaned up a few other spots. I swapped out the tip on my welder, set the machine to the recommended 14 gauge and did a practice T-joint. I ran it a bit hot and there is some undercut. I probably could have used a little more wire speed in this case. I cranked the machine up quite a bit since I'm welding right next to the other weld and I want good penetration. Little by little I ran a bead all the way across the top and it turned out much better. I also filled in a bit more near that hole. Alright, I think I'm happy with this. Now I can flip the bike over to the other side. Reapply the fire blanket and the ground clamp. I'll set the machine back to 14 gauge and fill that hole for the rear crack and run a bead over it. Then I'll run a few more beads over it and adjust the machine accordingly for good measure. I'm pretty happy with that. Next I'll do the same to the last crack. This was the most difficult to reach and I did short out the electrode a few times on that bracket. I think that looks okay, and then I'll flip the bike back over and get that little bit on the edge to connect the inside and outside welds at the front. Now I think I'm done welding. I don't know much about metallurgy, but from what I've read, post-heating steel can help reduce internal stresses and could possibly give it better strength properties. From my understanding, the faster steel cools, the harder it becomes, but also the more brittle it is. If it cools slowly, it will have more flex, but it'll also be strong. I'm sure that's only somewhat correct and it's a bit more complicated than that. But what I'm going to try to do is evenly heat this spot up with a MAP gas torch, and then over a span of about 20 minutes I'll gradually give it less and less heat. Definitely not very scientific, but if it reduces some internal stress with all those individual welds, then that would be a good thing. After that, I'll thoroughly clean this whole area up with various steel brushes. Then I'll scrape off any loose spattered beads with a flathead and some sandpaper. I accidentally left that socket off a few times, so I'll just use some sandpaper to get that shaft nice and smooth. I'll test fit the brake lever to confirm it moves smoothly. Now I'll rough up the paint on the entire rear of the frame with some steel wire wheels and sandpaper, then get it all nice and clean. Also, I'll check it over real good for more cracks, and I didn't see any. Next, I'll use some acetone to prep it for paint. Next, I'll set it back onto the lift and mask everything off I don't want painted, including the kickstand sensor and wire. I painted a few coats of 2-in-1 primer and might as well go ahead and primer the kickstand as well. Then I did a few coats of Duplicolor Perfect Match Galaxy Silver Metallic on the frame. This turned out to be a little more shiny than the original paint, but my friend had a slightly different silver that was nearly the exact match. I just don't remember the name. But I'm not too worried, this is an off-road machine and it looks good enough to me. Then I'll just spray the kickstand with any black color I got laying around. I removed the masking and let it dry overnight. Then while I'm waiting, I'll check out the swing arm bushing since I already have it apart. To fully remove the rear shock, unbend and pull out the cotter pin, slide off the washer and pull the pin out and the shock slides off. There are 2 bushings on the lower shock mount, be sure not to lose these. Remove this 8mm bolt and the chain slider and left side thrust cover comes right off. Go ahead and remove the other thrust cover, and if you don't see these, they could have fallen off at some point when you removed the swing arm. Next, I'll use a grease gun with lithium soap-based grease on the fittings, and I never got this to work super well on the bike. The grease always squirted out the sides like this. I was able to push a little bit of grease through the swing arm pivot, however, it seemed like the inner seals were pushed out in the process. What actually happened was that the bushing next to the seal was actually pushed out some as well by the pressure from the grease. Taking a look at the diagram, we can see that 6 is the inner seal, 5 is the inner wide bushing, 4 is the outer wide bushing, and 2 is the thinner longer part that the swing arm actually pivots on. Then 7 is the thrust cover that also acts as a seal. Grease is squeezed between the 2 bushings so that it has no choice but to be forced between the 2 bushing contact areas, or push the bushings out like it started to do here. For now, I'll just clean and lubricate both sides and use an extension, socket, and hammer to push back the bushings until the inner seals can sit flush. Let me know if you would want to see a video specifically about completely rebuilding the swing arm pivots. Probably not something to wear out much if you keep it well greased, but it would be cool to inspect them. Next, I'll go ahead and give all the parts a good cleaning. Now I'll install the thrust covers and the chain slider. There's nothing wrong with this one. They seem to be very durable, so I'll only replace it if it's actually broke because these things are kind of expensive. Make sure that the metal spacer is still on there, and I'll for sure use some blue Loctite. Next, I'll clean and apply some heavy-duty farm grease to the pivot. Be sure to install the 2 spacers and install the shock to the swing arm. Don't forget the washer, and I'll just use a new cotter pin. Now I'll roll it out to the bike and slide the shock under the mud flap and up to the top, then slide it in the mount. Line up the swing arm holes, insert the bolt from the right side and make sure those flats line up with that little nub. Install the washer and snug down the lock nut. Before I torque it down, I'll use some farm grease and install the kickstand by snugging up this bolt and tightening down the lock nut. Slide on the spring and bracket, then with the kickstand up, hook the spring with the vice grips. Then I'll apply a little bit of grease on the sensor contact. Next, if I lift the bike in the perfect position, the bolt for the shock will slide right in. This one should get some grease as well, but I forgot this time around. Don't forget the washer and spin on the lock nut. Then go ahead and take the bike off the lift and tighten the upper shock mount to 50 Newton meters. Don't forget the rubber cap, then I'll go ahead and plug in the rectifier and CDI. Then I'll torque the swing arm bolt to 80 Newton meters. I'll use the right size tap to clean up the threads for the peg bracket. I'll install the brake pedal stopper bolt to around where I remember it. Apply some farm grease and slide on the brake pedal assembly. Apply some blue Loctite and install the peg bracket. I'll just make these bolts nice and snug. Hook on the brake pedal return spring and brake light sensor arm. The manual says the brake pedal height should be 10 to 15 millimeters below the foot peg, so I'll adjust the stopper bolt to make that happen and tighten the lock nut. This also seems to be more of a personal preference kind of thing because after riding I felt like I had to reach too far down to use the rear brake for my liking, and later I moved it up a bit. For the rear brake arm, I'll grease the pivot points, slide on the spring and cylinder, then pull back and slide in the rod. Spin on the special wing nut, and turning it clockwise decreases free play on the pedal, and counterclockwise increases it. The spec is 20 to 30 millimeters. Next, I'll use some blue Loctite and install the passenger peg brackets. Don't forget the little wire holder that goes with the bottom bolt on the left side. Make sure the wire feeds through it and it's not pinched. I'll make sure these bolts are nice and snug. Next, I'll apply some blue Loctite again and install the left side peg bracket. Make sure the stud fits into the alignment hole. I'll make sure this bolt is nice and tight. Slide on the shift lever and Loctite and snug up the 10 millimeter. Real quick, I'll inspect some more of the welds before it's all back together. Couldn't find any more cracks. Next, with the bike in neutral, spin the chain around the front sprocket and wrap both sides around the rear. Next, with the 2 O-rings on the master link pins, I'll slide it on and apply 2 more rings. Next, I'll press the outer link on with a small clamp until the master clip can be properly clipped on. Make sure the closed sides point toward the chain movement direction and make sure it's seated properly in the grooves. Slide the chain cover on and install the 2 8mm bolts. Slide the skid plate clamps over the rear bar, thread on the front bolts, then tighten it all down. Loctite these 4 bolts, put the subframe in place, thread them in, and tighten them all down. Put the wiring harness back in place and plug in the turn signals. Zip tie down the wires, then stick on the rear fender and attach the front of it to the rubber bushings. I'll lay on the rear rack, then Loctite and tighten the 2 10s. Next, I'll connect the battery. Always disconnect the positive last and attach it first, or you risk shorting out a wrench on the frame. This lithium battery has these threaded inserts that are a bit of a pain to work with, but I'll lift the one up for the ground using a pick so I can get the bolt started. I use a lock washer on these so they don't come loose while riding. Slide the tank on the rubber pucks, then slide the rubber and metal bracket on the rear and install the 10 millimeter. I pretty much like to use blue Loctite with everything except the lock nuts on this bike, in case you haven't noticed. With the springs detached, I'll slide on the DG exhaust and tighten the 10 millimeter and 13 millimeter. Then I'll attach the springs. Don't forget to remove the bags and attach the fuel hose. Make sure you put the clamp on properly. You will see the mark from where it was last, and I always align it with this. Install the left side cover with the 2 screws. The right side cover just clips on the rubber grommets and the front part just pops in. Slide on the seat so the front locks into place and tighten the 2 10s. Make sure to thread them in by hand first so you don't cross thread them. Don't forget the taillight bracket with 4 10s, and I'll just connect and zip tie the wire up. Well, that's it. We're finally done.
Alright, let's go for a test ride.
And you might be thinking, will this novice weld repair even hold up?
I'll be honest with you guys, it's a little sketchy since I welded a structural part of my bike.
Could the frame just burst into pieces as I ride down the road?
Here we are in the twisties. Let's see how it handles. Oh, it feels like it always did.
To find this out, I took the TW200 out to California to ride the longest running organized dual sport ride in the world, called LA Barstow to Vegas. We started in Los Angeles to do some lane splitting and explore the beaches.
Oh, this is so cool. Just not worry about all the traffic.
But the actual ride starts in Palmdale nowadays.
Let's go to Vegas.
It's 450 miles in 2 days.
It doesn't snow in the desert.
Mostly off-road,
Nice.
across the Mojave Desert.
Oh, that's gonna be fun. It's a good way to start. Yeah. I think it's my front fender is packing full of mud. Up into the hills we go. Woo! It's really hard to like see because my visor just constantly gets mud on it. Alright. Well, at least the sun's out. Ow. Kind of getting used to sand. Ooh, I'm almost going 50. A ghost town over there. We're gonna make good time if we keep this speed up. This place is cool. Oh, my fingers are frozen. I have a feeling this day is gonna be much better than yesterday. Ew, there's like a little cave thing over there. That looks cool. Oh, it's like an old abandoned gas station. That's cool. Are you sure it's the right way? I don't see a track. If you say so. Oh my goodness, that's a lot of bottles. Car seats, tires, furniture, appliances. We got it all out here. Oh, it's a car door. Hi. Crap. It is Sunday. Ooh, this is some neat looking bushes. Ow. I don't have a lot of power on this bike. Sunday. Gotta get to Vegas, gotta get to Vegas. I just want to make it. Oh, I'm gonna have to drop gear down low. There we go. Ow! Follow the power lines. I'm sure that'll take us right to town. Full throttle! Okay. Oh, hello. Ooh, yes, very deep sand. Oh my gosh. This thing just wants to wander. I don't know if I'm going the right way anymore. I don't know where to go. I am lost. Wait, what? Yeah. Oh, that's just a random airplane. Follow this guy. Looks like he knows where he's going. Ooh, it's chilly. This is 5th gear, wide open throttle right here.
place. And eventually, you end up in Vegas.
Oh, is that Vegas? What? We're almost there. Yeah, I'm just gonna follow these guys right here. They probably know where to go. Oh, we made it! Oh, that's funny. Welcome back, everyone, and I gotta say that was probably the most mud I have ever gotten on the TW200. And even with the power washer, it took quite a while to get all that stuff off of there. But anyways, not only did I go on that trip, but it's almost been a whole year since I made that repair, so let's go ahead and see how it held up. So it really looks pretty much the same as when I finished it. I don't see any cracks anywhere on it, so that's really good. I'm definitely happy with this. And you never know, it might last a very long time. It'll definitely be something I keep an eye on. And also, let's take a look at the other welds. The ones on the cross member that support the rack, I don't see any cracks forming on those again, and I've definitely took this thing on some moto camping trips, really put it to the test. And also the muffler bracket looks great too. So that really makes me happy to see that those welds are holding up. I'm actually kind of surprised. I didn't think they would hold as good as they are. And I'm definitely not a professional welder, so I would take all my advice as a grain of salt. I'm just a person that likes to learn how to do stuff themselves. I'm somewhat of a practitioner, I guess you could say. But anyways, guys, I'll let you know if I have any more problems. Hopefully I don't have to make any more welding videos for a while. Definitely beats buying a whole new frame for around $700 to $800. And also, I have a theory of why this may have cracked in the first place, because I have these aftermarket wide foot pegs on here, and it's got this long bracket with the peg on the end, and every time the bike goes down, it uses this bracket as a lever to put a lot of torque right in that area. So that's something to keep in mind about the aftermarket foot pegs. But anyways, guys, I hope you enjoyed this video. I got a TDubsKid show coming up next, and I got some other cool videos with the J&S engineering headlight and some other stuff I think you guys will find useful. But thanks for watching, ride safe, and I will see you guys next time. Peace out. Ooh, that looks like fun over there. One of the zip ties broke, but the other one's good, so it's fine. Oh, my fender flew off over that bump.